Okay, so I've got a particle that's following, has a motion that follows an equation shown here. Okay, and we know that theta is given this. So these are given in with respect to time, but they're polar coordinates. That is, the radius or distance from the center and the angle from the horizontal axis. Okay, that's the definition of polar coordinates. So the equations are given in that. So, and I want to find the velocity and acceleration at 2 seconds. Okay, now because I'm using polar coordinates, I'm going to go ahead and uh, find r dot, r double dot, and theta, theta dot, theta double dot, so that then from those I can put together and find the total velocity, total acceleration in each direction. So r, okay, is given by b times 2 plus cosine of pi t. Okay, if I'm going to take a time derivative of this, okay, b is constant. Okay, so that first term 2b, that goes away because 2 and b are both constant. So all I'm left with is the b times the cosine pi of, I'm sorry, the cosine of pi t. So with that one, I take the derivative of the inside times the derivative of the outside. And what I'm left with, again, going from cosine to sine or taking the time derivative, the derivative of cosine, I go from cosine to negative sine, okay? And I pull out the derivative of what's on the inside. So instead of pi t, I pull out pi. So basically what I get is the following: negative b pi times the sine of pi t, okay? And that's the time derivative of b times cosine pi t. Again, I take the derivative of the inside, which is pi. I bring that outside, and then I take the derivative of cosine, go to negative sine. Okay. Doing the same thing to go to r double dot, take another time derivative. So again, b and pi are both constants, so those are left alone. I take the derivative of the inside, which I pull a pi out, and then sine goes to cosine. So basically the negative stays alone. I add another pi to the outside, and then switch this to the cosine of pi t. Now what I do here is I'm going to go ahead and I'm going to plug in, because again, I'm trying to figure out what's going on when t equals 2. So plugging in here, t equals 2, cosine of 2 pi is 1, so this becomes 3b. The sine of 2 pi goes to 0, so this all goes to 0. And again, the cosine of 2 pi goes to 1, so this just becomes negative b pi squared, like so. So that's r dot, r double dot at t equals 2 seconds. Now I'll do the same thing with my thetas. Okay, tells me that my theta is pi times t. I'm going to take a time derivative of that, and I'm just going to be left with pi. Take another time derivative, and then that goes to 0 because pi is constant. Okay, now plugging in 2, this theta becomes 2 pi, and then everything else, doesn't matter. It's are constant with time. Okay. Now that I have r dot, r double dot, theta, theta dot, theta double dot, I can go ahead and figure out, okay, well, the velocity in the r direction. So what we're looking at is my r direction heads out like this, okay, and my theta direction is perpendicular to that r, like so, okay. Um, so that's what we've got, and that's what we're looking at. So r at this point, the velocity in the r direction uh, is, by definition, r dot, which we found up there equal to 0. Okay. The velocity in the theta direction, if I look up the equation, is r theta dot, where r is 3b and theta dot is pi. So that becomes 3b pi. And now this, okay, because VR is 0, the total velocity is just that velocity right there. Okay, so we'll do the same thing with the acceleration in the r direction. That, when I look that up, is r double dot minus r theta dot squared, and I plug in what I've got, which is negative b pi squared, that's r double dot, minus r, which is 3b, times theta dot squared, which is pi squared. So from that, adding those up, I get negative 4b pi squared. Okay. The acceleration in the theta direction is r theta double dot minus 2r dot theta dot. Well, theta double dot goes to 0, and r dot goes to 0. So this acceleration is 0. So the only acceleration I have is that acceleration in the r direction given right here. So with these problems, recognize that you've got polar coordinates. Once you see that, then you can easily go through, well, maybe not easily, but you go through and you find r dot, r double dot, theta, theta dot, theta double dot, and plug those values into those polar equations for velocity and acceleration to determine what those velocities and accelerations actually are.